This video is to demonstrate a few different transmittance effects as a part of my assignment for CS7GV3 real-time rendering. Here I have three different models: the Utah Teapot, Suzanne the monkey from Blender, and the Stanford bunny. I will be using them along with a few different cube maps as environment textures. These are four different shaders to display four different transmittance effects: reflection, refraction, Fresnel, and chromatic dispersion. The first shader is the reflection shader. This shader creates a material that behaves like a mirror by perfectly reflecting the environment around objects. This can be seen as I move the camera around. Since these objects are locally illuminated, we do not see them appear in each other's reflections even though they are beside each other. That is something that can only be achieved with ray tracing. And as seen for the next few effects, this would repeat since it is still local illumination. The second shader is the refraction shader. Instead of bouncing rays off the surface of the object in the reflection shader, this one bends these light rays inside the surface, causing whatever is behind that object to appear distorted. This level of distortion can be modified when the index of refraction, which is the IOR value here, as it can control how strong the bending effect is. Here, I have a few preset IOR values for water, glass, and diamond. I also explored additional IOR values for different materials and set the scale for the IOR values accordingly. An IOR of 1 makes the object disappear as light passes through it perfectly. The IOR of air is 1, which is why it is invisible to us. Also, higher IOR values can give a more distorted look. And as you can see here, odd things happen when the IOR is set below 1 as well. The third shader is the Fresnel shader, which blends both reflection and refraction effects. In most materials in the real physical world, objects usually display a blend of reflection and refraction rather than just one or another. Fresnel equations allow us to define this behavior mathematically. As you can see here, the edges of all these objects catch more of the environment reflection, while the front shows more of the refracted background. I also have a slider that lets me define this behavior and the balance of how strong the reflection is compared to the refraction, so that I can go from a subtle glass look to something closer to a chrome. The final shader is the chromatic dispersion shader. It simulates how real glass splits light into different colors like a prism. Each color channel, which in this case is R for red, G for green, and B for blue, uses a slightly different index of refraction or IOR value. This means that light bends at different amounts for each of these color channels, so a subtle or clear color separation can be seen based on how different these IOR values are. Finally, I want to talk about the Skybox. I'm using a Cubemap as the Skybox, and every reflection and refraction sample comes from that texture. If I swap the environment, the look of the materials changes instantly, even though the shader code stays the same. This is why good HDRI or Cubemap lighting is so important for testing shaders created with PBR or physically based rendering effects.